The water we've already used, called wastewater, is generally treated before being released into our rivers or oceans. Recycling water for drinking means taking this pre-treated wastewater and purifying it to exceed drinking water standards so we can use it again, rather than waste it. How is this done? The wastewater passes through 7 barriers to purify it. The key ones to understand are microfiltration, reverse osmosis, and advanced oxidation using light and hydrogen peroxide. To explain, microfiltration involves passing the pre-treated wastewater through membranes that remove particles and microorganisms, including bacteria and some viruses. In the reverse osmosis stage, this filtered water is forced through a special membrane, which acts like an artificial kidney at high pressure to remove impurities such as dissolved salts, viruses and pesticides. Finally, during advanced oxidation, the water is exposed to ultraviolet light and hydrogen peroxide. This process removes remaining traces of organic compounds and organisms. The result is purified water of a very high quality. In fact, the water exceeds drinking water standards. As with all other sources of water, the water is disinfected with chlorine. There are 2 ways purified recycled water can be introduced to our drinking water supply: direct potable reuse and indirect potable reuse. Direct potable reuse means putting the purified recycled water directly into the drinking water supply. This is an energy and cost-efficient method of recycling water, as it eliminates the need to pump water to storages and then retreat water. Direct potable reuse schemes are growing internationally, with countries such as the United States and South Africa increasingly using it as an important water source. Current state regulation doesn't enable direct potable reuse schemes in Queensland. This may change in future as acceptance and understanding of these schemes increases over time. Indirect potable reuse means adding the recycled water to other untreated water, generally in a dam. The purified water mixes with the dam water and is then treated again in a conventional water treatment plant before entering the water supply. This is a water supply option that is currently being used in over 20 sites across the world, including California, London and Singapore. Sometimes indirect potable reuse is unplanned. This happens when communities along a river or waterway discharge their treated wastewater into the river. This water then flows onto communities downstream, where it's extracted and treated for drinking water. This unplanned, indirect potable reuse is common in Australia and around the world. In South East Queensland, we have the ability to produce purified recycled water through the Western Corridor Recycled Water Scheme. The scheme was built during the Millennium Drought and is not currently being used because our surface water supplies are high. At the moment, the 3 advanced water treatment plants that make up the scheme are in care and maintenance until they're needed in a future drought. Recycling water for drinking is a climate-resilient option. It is marginally impacted by drought because we generally use less water during dry times, so there's less wastewater available for purification. To compare some water supply options, recycled water is less energy intensive and less expensive than desalination, but it requires more energy to produce than surface water and is therefore more expensive. The regulators of water recycling schemes here in Australia and worldwide ensure the monitoring of water quality standards are higher than those applied to most other water supply options. Regardless of whether recycled water is introduced to the water supply directly or indirectly, it is a resilient water source which can result in reduced nutrient discharge to waterways.